Hello everyone, today we will solve computer networks module 2 important questions. The first question is what is bit oriented framing and its frame pattern? Explain with example bit stuffing and unstuffing in bit oriented framing. Bit framing is a way to send a sequence of bits over a network. The data could be text, images, audio or video. To separate one frame from another, we use special bit called flag. Okay, first bit oriented framing andre it is a way to send a sequence of bits. Okay, this is a frame. Flag pattern andre it used to mark start and end of the frame, and this is a special 8-bit pattern it is used. There is 8-bit and then starting and ending, like first and 8-bit is 0 and then 6 ones are there. Frame pattern in bit oriented framing. Okay, this is a frame pattern. In bit oriented framing, the frame is structured with several fields including flags to mark beginning and end of the frame. This is a general frame pattern is used. Flag, okay, flags are used to mark beginning and end of the frame, and there is address, control and data, FCS and then flag. This is a frame. Okay, frame in bit oriented protocol. See, this is flag which is used to mark beginning and end of the frame, and then we have header, and then we have a data information, and again trailer, then again flag. Sometimes flag pattern can accidentally appear inside the data. If it happens, the receiver may get confused and it thinks it's the end of the frame when it's not. Okay, we will see this. See, I will tell bit stuffing and unstuffing in this using this figure. What happens is if a bit fat if a flag is flag, what is flag? It contains it makes sure it tells that okay, what is wait flag pattern. ಇವಾಗ ಫ್ಲಾಗ್ ಎಲ್ಲಿ ಯೂಸ್ ಮಾಡ್ತಾರೆ ಅಂದರೆ ಬಿಗಿನಿಂಗ್ ಆಫ್ ದ ಫ್ರೇಮ್ ಆ್ಯಂಡ್ ಎಂಡಿಂಗ್ ಆಫ್ ದ ಫ್ರೇಮ್. ಓಕೆ, ಇಫ್ ಬಿಗಿನಿಂಗ್ ಆಫ್ ದ ಫ್ರೇಮ್ ಇದ್ದಾಗ ಒಂದೊಂದು ಸತಿ ಕನ್ಫ್ಯೂಷನ್ ಆಗುತ್ತೆ, ಯಾಕಂದರೆ ಡೇಟಾ ಕೂಡ ಸೇಮ್ ಇರ್ಬೋದು, 0 ಅಪ್ ಟು 8 ಥರ. ಸೊ ಟು ಗೆಟ್ rid of that confusion, what we will use means bit stuffing and unstuffing. Okay, in bit stuffing what will happen means the sender adds an extra 0 bit whenever it finds an 5 consecutive ones ಬಂದಾಗ ಅದು ನೆಕ್ಸ್ಟ್ 0 ಆ್ಯಡ್ ಮಾಡುತ್ತೆ. ಏನು bit stuffing ಅನ್ನೋದು add 0 to when there is a 5 consecutive 1 in the data. This way the flag pattern won't accidentally appear in the data. Okay, example we will see. Original data to send, this is the original data. Okay, and then step 1, look for 5 consecutive ones. Here are there no 5 consecutive ones. See, 1 2 3 4 5. After 5 ones we should add 0 here, and then here 1 2 3 4 5. Okay, there are 5 consecutive ones. So here 1 0 and here 1 0 we will add. Okay, after data stuffing will look like this. Okay, then we should do unstuffing. Unstuffing means we should remove, like when the receiver gets the data, it removes the extra bit. When receivers get the data, it removes the extra 0 bit that was added during stuffing. If it removes the extra bit 0, then we will get the original data. Okay, see, if we remove this 0, we will get this same as original data. They'll remove this 0 and then this is 0. After that we got the original data. Then the second question is explain the 3 different HDLC frames with a diagram. HDLC, high level data link control, is a bit oriented protocol. Okay, it is not byte oriented protocol, it is bit oriented protocol. Point to point protocol bandu byte oriented protocol. Remember differences between these two. Okay, it is used for communication between 2 devices. It defines 3 types of frames of data transmission. One is information frame, supervisory frame, unnumbered frames. Okay, information frame is called as I frame and supervisory frame is called as S frame. Unnumbered frame is called as U frame. Okay, information frame which carries user data and control information. In the name only is there. See, information means data, something like any data can be the information. So it carries user data and control information. Supervisory frame means that called as S frame, and it is used for flow control and error control. Unnumbered frame means U frame. It is used for system management and control purpose. Here is the HDLC frames. See, what you can easily remember for exam. If you know this frame is, every definition you can write aram say. In the frame what and all will be there, flag beginning and ending you will write flag. Then address control is same for everyone, and FCS also is same. Okay, FCS also is same. In first for iframe, what will be there? User information. In S frame, nothing will be there. Okay, like information. It is used for flow control and error control. In U frame, management information like system management and control purpose will be there. This is the HDLC frame. What will be there in one frame? It's like flags, so beginning and ending flag, and starting we have address control, and then FCS. And then in middle user information, and for S frame nothing, and for U frame management information. Okay, now one by one we will see what is meant by information frame. Iframes are used to carry data, user data, along with control information for error detection and flow control. In information, there will be control also, like error detection and flow control. Both will be there. They support backing, meaning they carry both data and acknowledgement in the same frame. Okay, flag is what? It marks the start and end of the frame. Address, it identifies the sender and receiver. Control means contains sequence number and error control info. Okay, it contains the sequence number and error control info. Data, user data. FCS is frame check sequence for error detection. Okay, frame check sequence for error detection. Now control field format for iframe. We should see the control field. Control field. Okay, these are the diagram. This is control field. N of S means send sequence number. Okay, this is S is send, R is receive sequence number. Then P of F means pole or final bit. This is the general format, like send sequence number and receive sequence number. Okay, N of S, send sequence number 3 bits, indicates the sequence number of the frame being sent. Okay, then receive sequence number 3 bits, acknowledges the receipt of frames from the sender. It acknowledges whether it's sent or not. Okay, P by F means pole by final bit, used to manage communication. Pole, when the primary station is requesting information from a secondary station. Final, when the secondary station is responding to a primary station. This is very easy. See example, an iframe may contain text or video or image data along with acknowledgement numbers. Next, supervisory frame is for flow control and error control. When piggybacking is not possible, they do not carry user data. There won't be any data in supervisory frame. Okay, flag same, marks start and end of the frame. Address identifies senders and user. Control indicates type of supervisory frame. Okay, now it indicates the type of supervisory frame. Here control, it contains sequence numbers and error control info. Here sequence number will be there. Here sequence frame will be there. Okay. Then FCS, same frame check sequence for error detection. Control field format for S frame. Here no data will be there. Okay, 10 code P by F N of R. N of R is same. Receive sequence number 3 bits. It acknowledges the last frame received. Okay, 10 indicates this is the S frame. Okay, it specifies the type of S frame. 00 RNR reject SREJ means there are 4 types: receive ready, receive not ready, reject, selective reject. Okay, receive ready, receive not ready, reject, selective reject. Receive ready is it acknowledges that frames have been received and the receiver is ready for more frames. Receive ready acknowledges that frames have been received and receiver is ready for more frames. Receive not ready acknowledges frames but indicates that the receiver is not ready for more. Reject means negative acknowledgement for lost or damaged frame. Selective reject, it requests transmission for a specific frame. Pole or final bit means used for managed communication. N of R means receive sequence number, it acknowledges the last frame received. The next frame is unnumbered frame, what it is used to manage the system management and control purpose such as establishing and terminating connections. Same fields, address, control, optimal data, and then FCS. Here it contains the control information, and optimal data is system management, not user data. Okay, control field will be the means code P of F modifier. Code is 2-bit prefix identifying the type of U frame, and then modifier is 3-bit suffix indicating the specific functions of the U frame. There are three types of U frame. One is set asynchronous balanced mode, which establishes a connection. Disconnect means terminates the connection. Unnumbered acknowledgement means acknowledges a unnumbered frame. Okay, then the differences between Aloha and slotted Aloha. Aloha They can send data at any time. In slotted Aloha, only at the start of a fixed time slot only they can send the data. Vulnerable time of Aloha is twice the frame time. The collision can happen if two devices send data at any time, even if they are bit out of sync. Okay, here vulnerable time is equal to the frame time. Collision can only happen if two devices send data at exact start of the same time slot. Here whenever data can send, there will be a collision, but here there should be only happens when there is exact start of the same time slot. Collision more likely happen because transitions are random and not synchronized. Here collisions are less because devices and data fixed time slots, reducing chance of overlap. Efficiency is lower here and efficiency is higher here. Maximum throughput is 18.4% and here 36.8%. Here low because of many collisions, because high because the collisions are reduced. Retransmission, here random time after a collision, making it harder to avoid another collision. Retransmits only in the next time slot, making collisions less likely. Synchronization means here no synchronization. Here time slot synchronizations will be there. Channel utilization, less efficient, more efficient. These are the frames. Okay, see, in this the data will be sent on any time, means like all the devices can send at a time, so there will be a collision. See, collision duration, this is the collision duration, many data is collabed. Here time slot, frame slotted Aloha, here slot 1, slot 2, slot 3, like slots will be there. In this this subject is very important. You should write diagrams. See, vulnerable time also. Next question is explain CRC encoder and decoder for 4-bit data word. CRC is cyclic redundancy check. Okay, what it means, it is a method to detect errors during transmission. It involves encoding data before sending it and decoding it the receiver's end to check for errors. Okay, it involves encoding before the data is sent, decoding it to the receivers to check the errors. Okay, 4-bit data word. The process involves senders and receivers. Sender encoder, receivers will decoder. Sender adds extra bits, checksum to the original data using divisor. Decoder checks the received data using the same divisor to detect errors. CRC encoder. Okay, the encoder takes 4-bit data word and performs the following step. There will be an example. See, first we will take the data word. This is an example, and then we will choose the divisor. Okay, this is one example. Same example, we'll choose some bits. Okay, then again here we will add the data word with 3 zeros because there will be 4-bit. Means we should take one lesser. Okay, if it is 4 means we will take 3 zeros. If it is 5 means 5-bit data word means we'll take 4 zeros. Okay, one lesser you should take, like that. Now we added data word. It will become 11010000. Then we will perform modulo to division. I will show you an example this. Okay. Then the remainder becomes this checksum. Example 011. Okay. Then what it means, it is there will be some error. Okay. So append the remainder to the data word to form the final data word. Now here what we should do means instead of 3 zeros we should put 011 and the final code word will be 1101011. So now we will do decode. CRC decoder. The decoder receives the code word and perform the same division using the same divisor. Steps again, example will take this same and then divide the code word by using divisor. Okay, now if we do same divide means at last we should get all zeros. If we get all zeros means there is no error. If we not get zeros means there is an error. See one example. Example, we'll take 4-bit data word, that is 1101. Okay, and the divisor we will take 1011. Now we should do we should do division. Okay, and then XOR method we will use. Step 1, append zeros, means we should add 3 zeros because they gave in example there are 4-bit data word, so we should reduce 1 and we should take 3 zeros. Okay, we will add at last 3 zeros. See, 1, 2 and then 3 zeros. Then here we will write divisor value. Okay, then we will put here 1, we will add 1 and then we'll put this divisor down 1011. Okay, then we will execute XOR. See, 110 101 011 110. The thing is XOR, you know, if we get 00 then we will get 1. If we get 1 then again no, if we get 100 then again will be 0. 11 also 0. 10 if we get 1 If you get 0 1 1, if you get same input means we will get 0. Okay, if you get different input means we will get 1. That's all XOR operation. If you should perform for all this. See, 1 1 0 1 0 1 0 1 1 1 1 0. This 0 we should cancel, and then this 1 we should put here. Then again this 0 we will add down. Again we will copy this divisor value here. Again we will perform the XOR 1 1 0 1 0 1 0 1 1 0 1 1. Again we will cancel 0 here. This 1 we will add here. Okay, and then next 0 we will put down. Again we will copy the divisor, that is 1 0 1 1. Then again we will perform XOR 1 1 0 1 0 1 1 1 0 0 1 1. Okay, then again we will cancel this, and then we will add one more 0, and then we will copy this divisor, and then we will perform XOR. Then 1 1 0 0 0 0 1 1 0 0 1. Okay, again we will cancel this 0, and this 3 will be there. No, that will be our reminder. See, in our code word we should write this data word and then reminder. Okay, what we got reminder, we will replace this zeros. We will yeah, same. Then again this is encoding. Okay, now we should do decode. How you will do decode means, instead of zeros you will put what reminder you got, that's the 0 0 1. Then again we should do division. This is the divisor, and you wrote your code word, and then we'll copy this divisor down here, and then you will perform the XOR 1 1 0 1 0 1 0 1 1 1 1 0. Okay, then we will cancel here 0, and then you will add 1 here, and this 0 we will get down here, and then again we'll copy same this divisor here, and again you will perform the XOR 1 1 you will get 0 1 0 will get 1 0 1 1 0 1 1. You'll copy down this 0 here. Okay, you will cancel this 0, and you will add 1 there. Then again you will write this divisor here, and then you will perform the XOR operation 1 1 0 1 0 1 1 1 0 0 1 1. You will cancel this 0, and then you will add 1 here. Again you will perform the okay, this 1 you will add there, and again you will copy this 1 0 1 1 divisor down, and again you will perform the XOR operation. Okay, 1 1 0 0 0 1 1 1 0 1 1 0. You got reminder all 0, then there is no error in the data. Like that we'll check the CRC. Okay, the next question is explain the stop and wait protocol with FSM and the flow diagram. What is stop and wait protocol? It is a flow control and error control protocol in which the sender sends one frame at a time and waits for acknowledgement from the receiver before sending the next frame. Okay, stop and wait protocol means sender sends one frame at a time. It can't send many frames together. Okay, and it waits for the acknowledgement. Receiver, okay, now from the receiver before the next frame. Steps: sender sends the frame, receiver checks if the frame is error free. If the frame is correct, then receiver sends the acknowledgement. If the frame is corrupted, the receiver discards it and waits for the new frame. Okay, arthumena. Next is sender. Sender waits for acknowledgement. Okay, yeah, sender waits for acknowledgement. If acknowledgement arrives on time, the sender sends the next frame. If the acknowledgement is missing or corrupted, the sender retransmits the frame after the time out. Then if the acknowledgement time is up means, then sender will resend the frame again. These are the component and description: frame, acknowledgement, timer, CRC. Error checking method. Frame is what? A chunk of data sent by the sender. Acknowledgement, a single signal. A signal sent by the receiver to confirm the frame was received correctly. Timer is used by the sender to handle lost or delayed ASC case. CRC means error checking method to detect the corrupted frames. It will check if it can detect the corrupted frame. Here the sender state. In sender state there are two states. One is ready state, another one is blocking state. Ready state, what will be do means the sender waits, okay, for the packet from the network layer. The sender waits for the packet from the network layer. When the packet arrives, the sender makes the frame, saves a copy of the frame, sends the frame to the receiver, start the timer to wait for an acknowledgement. Okay, this task will do by ready state. Okay, the sender waits for the packet from the network layer. When the packet arrives, the sender makes a frame, saves a copy of the frame, send the frame to the receiver and start the timer to wait for the acknowledgement. After this, the sender moves to the blocking state. And in blocking state, what will happen? In the state, the sender waits for acknowledgement from the receiver. There are three possible events: timeout occurs, corrupted occurs, error free occurs. Okay, now timeout occurs means if the acknowledgement doesn't arrive on time, the timer expires, the sender resends the saved frame and restart the timer. Okay, then again, what corrupted acknowledgement arrives means if the acknowledgement is corrupted, the sender discards the corrupted acknowledgement and waits the next one. It will do discards, and again it will wait for corrected acknowledgement. Error free acknowledgement arrives means it stops the timer, it discards the saved copy of the frame. Okay, it will be saved one copy of the frame. Now it will discard it. Then it will move back to the ready state. In receiver state, what will happen means the receiver is always in the ready state. Two things can happen: error free frame arrives, corrupted frame arrives. That's all. If the frame is correct, the receiver extracts the message from the frame, delivers the message to the network layer, sends the ACK. Corrupted frames occur means if the frame is corrupted, the receiver discards the frame and does not send any acknowledgements. Okay, here is a flow diagram, and this is the diagram. See, the in sending node and the receiving node, there are two state: ready states and blocking state. Okay, in ready state, here start. Okay, packet came from network layer. Make a frame, save a copy. Okay, save a copy. Yeah, ready frame, save a copy will be there, because if the acknowledgement it won't reach means there will be a timeout. So saved frame will be resent to the receiver. Yeah, saves the copy of the frame, and then send the frame or start the timer. And then if all the tasks done, it will go for blocking. Blocking, what they will do? Blocking will if the timeout resends the saved frame and restart the timer. Okay, then again it will go to blocking. If the corrupted acknowledgement occurs means it discards the acknowledgement. Free error package came means it stops the timer and discard the saved frame, and it will go to ready state. In receiving node, only two possible: one is corrupted frame arrive or else error free frame arrives. There will be it will go to ready state. Receivers will be always in ready state. Start ready. See the frame. Okay, now flow diagram. This is the network, and this is sending node, and this is receiving node. Here the network, and here is data link. Here data link is the network. From one network, the packet is sent to data link layer. Data link to again it will go frame, next receiving node. Okay, now then it will receive. After going frame, it tells that, and then it again here acknowledgement will send here. Then the next packet will come, and then here the frame is lost. So they won't receive any acknowledgement. So the frame will send again. Then again they'll receive the acknowledgement. Then again one more packet to data link, and then data link will convert to a frame. They send again here acknowledgement lost. Here acknowledgement lost also, again frame will resend. Here then again here time. Yeah, if acknowledgement not sent also, this frame will be reached to this network, so it will be seen as duplicate. This is our flow diagram. Sequence and acknowledgement numbers in stop and wait protocol. In stop and wait protocol, the sequence number and the acknowledgement numbers are used to avoid duplicate packets. Okay, and ensure that reliable data transmission. Sequence number means it identifies each packet to introduce the sequence number. Sequence numbers are added to each data frame set from sender and receiver. Sequence numbers will start from 0 and acknowledgement number will start from 1. It is alternate between 0 and 1. Example of sequence number 01 01 01. In acknowledgement numbers also same, it receives the receiver. Okay, now after the receiving a frame, the sender sends the acknowledgement back to the sender. The acknowledgement contains the acknowledgement number which tells the senders which frame number was received successfully. Okay, then acknowledgement numbers always start at 1, alternate between 1 and 0. Example 101010. What is PPP and what are the services provided? PPP, it is the point-to-point protocol, is widely used for connecting home computers to the internet. Okay, it is widely used for connecting home computers to the internet. It is a protocol that helps to manage how data is transferred between two devices, like your computer and the server of an internet service provider. What are the services? Means it is gives the encapsulation of data wrapping and the starting and stopping connection. It can error check, authentication, and works with the data different data types, multi-link PPP, so faster speeds, and then assigning an IP address. The 7th question is solve using cyclic redundancy check for data word 1001 and the divisor is 1011. Okay, we should solve this. First, what we should do, we should add the zeros to data word. Okay, there are 4 bit now, so we should add 3 zeros. Okay, for dividend. Then we should do XOR operation. Okay, first we will add 1 here and then we will do the operation. 1 1 we will get 0 and then 0 0 will get 1, 0 1 will get 1 and then 1 1 will get 0. Okay, 1 0 here will be there. We will cancel this 0 and then this 0 we will add here. If 0 comes, all the if divisor will be 0. 0 0 again here 1 0 and then 1 0 1 0 0 0 0 0 0 and this 0 we will add here. Okay, this 0 we will cancel and then this one we will add here. Okay, then again this for 1 no, this divisor we should take here and then again we should perform the XOR operation. 1 1 will get 0 and then 0 0 0 0 1 1 0 1 1 again last 0 we will add here. So this 0 will cancel and then this 0 we will add here. Okay, then again so 0 we got no, in this also leftmost bit we should use 4 zeros. Then after 0 0 0 1 0 1 1 0 1 0 0, so we got 1 1 0 as reminder. So then what we should do means in the code word this reminder, instead of this 3 zeros we should add the reminder 1 1 0, this data word plus reminder. This is we done encoding. Okay, what we got here, this code word we will put here. Okay, this is a code word what we got and then this is a divisor, then we should perform the XOR operation. 1 we will put here and then 1 1 we will get 0, then 0 0 0 0 1 1 1 1 0. Okay, then this 0 will cancel, this we got no 0 we will add here and then for 0 leftmost no, so again divisor will become all these zeros. This 1 we will add here and then we will perform the XOR. 0 0 0 will be there, 1 0 1 0 0 0 1 0 1 and then this 1 will carry out here. Okay, then again this 0 will cancel and this 1 will be added here. Okay, this is 0. Then this divisor will add here, it will perform the XOR operator, will get all zeros. Okay, code word again this also will become zeros. If we come all zeros, then the data word is accepted. Okay, see if the if something is corrupted, like in the code word instead of here 1, if we put here 0 means or will not get reminder as all the zeros, so data word will be discarded. The next question is about we should explain the flow diagram of CSMA CD. Okay, here is the answer and this is the figure, collision and absorption in CSMA CD, and this is the flow diagram. These are all important questions.